Zero Trust is a security framework where access decisions are based on the verification and authorization of all users and devices, whether inside or outside the organization's network. This approach ensures that every attempt to access resources is trusted and verified before being granted. As organizations shift their focus from connectivity to a security-oriented mindset, implementing Zero Trust becomes crucial in protecting sensitive information and operations. The implementation is a phased approach that requires detailed planning to address the unique needs of each phase, ensuring successful achievement of security goals.
In the modern network security context, particularly when employing a Zero Trust framework, it is crucial to strategically deploy monitoring and enforcement tools across different sites based on their specific characteristics and business criticality. This concept is effectively illustrated through a matrix that categorizes sites by the expected variety of connected device types, a measure of device heterogeneity, referred to as expected endpoint entropy, and the business criticality of these sites. Sites with higher expected endpoint entropy, such as those with more than 25 types of devices, are classified alongside columns indicating business criticality ranging from very low to critical. This classification aids in determining the priority and methodology for deploying network monitoring modes and eventually enforcement modes. For example, locations with a high variety of devices and critical business operations require a sophisticated and robust initial monitoring phase to avoid any business disruptions while ensuring comprehensive security coverage. The categorized deployment plan aids organizations in fine-tuning their security measures to be both efficient and effective. By starting the monitoring phase in areas with a high variety of devices, organizations can gather vital information and insights that streamline the future rollout of network security measures to other sites. This strategic approach not only optimizes security resource allocation, but also minimizes potential disruptions to critical business functions, thereby enabling a smoother transition to full enforcement regimes under the Zero Trust model. The matrix serves as a clear visual guide to implementing this phased approach according to the unique needs and risks associated with various organizational sites.
The initial step in implementing Zero Trust is to discover which entities exist on the network and understand the governing policies. Organizations should use a discovery or monitor mode for as long as possible, parallel to enforcement tasks. Monitoring provides visibility over endpoints, uncovering a wide variety of entities and their suspected identities. This perspective is key where dynamic classification isn't applicable, and an on-site presence can be beneficial for identifying entities that cannot be otherwise classified. The enforcement paradigm for network endpoints has evolved from a single appliance approach to distributed enforcement points across multiple locations. Implementing enforcement varies between greenfield environments, which are new builds, and brownfield environments, which are existing infrastructure. Regardless of the approach, careful planning and documentation of lessons learned in the monitor mode can significantly ease the transition to enforcement mode, reducing potential impacts on network usability. Authorization of entities stands as the most significant outcome in the Zero Trust journey. This involves addressing specific considerations regardless of an entity's identification status, whether in greenfield or brownfield environments, or with unique cases like unified communications devices. The primary goal in implementing Zero Trust is to facilitate business continuity, ensuring that endpoints' role are neither unduly restricted nor permitted access to unauthorized resources. The practical implementation of segmentation within Zero Trust should begin by focusing on policy and governance and identity pillars. This requires a deep understanding of contextual identities and detailed traffic flow analysis between clients, VLANs, and external environments. Organizations often err by assuming small, lab-based endpoint samples suffice for understanding traffic flow, without accounting for external interactions, which are essential to business functionalities. In the endpoint discovery phase, commonly referred to as monitor mode, organizations gather insights on entities without impacting network operations. This phase leverages existing network protocols to understand which devices are present and provides insights into the contextual identity and authorization results of endpoints without enforcing these results initially. The acquisition of this knowledge allows continued business operations while laying the groundwork for more restrictive access controls. When initially applying monitor mode, organizations face challenges such as assuming a finite monitoring period and underestimating the time required for device discovery, especially in the absence of a robust asset management system. The careful allocation of staff to resolve discrepancies and map networks is vital for a successful implementation. Comprehensive identity processes involving device profiling, business functionality determination, and meticulous asset documentation play a crucial role in minimizing vulnerabilities and risks. Endpoint traffic monitoring complements contextual identity determination by applying an unenforced authorization result, enriched with device-specific data, to endpoint sessions. This information, when paired with monitoring systems, augments understanding of network interactions. Recognizing sites with a variety of common enclaves provides significant value in this monitoring process, allowing for effective traffic pattern mapping based on identity, cut through dynamic IP address changes, and enhance network security understanding. Organizations often face challenges in site selection and timeline minimization when rolling out monitor mode. It's crucial to ensure the selected site's business criticality supports the process without disrupting operations. Various ways to apply monitor mode, such as authentication adjustments and limited enforcement, can cater to different operational scenarios. Emphasizing a balanced approach helps in smoothly transitioning from monitor to enforcement mode, ensuring minimized impacts on the organization's routine activities. The application of enforcement within a zero-trust environment focuses on policy distribution near endpoints for maximum effectiveness. This involves re-evaluating existing single-point enforcement systems like firewalls, which may host excessive rules. The shift toward a more layered approach requires comprehensive audit processes to minimize outdated rules and enhance security policies. Dynamic rule implementation, facilitated by distributed enforcement, allows for more flexible network access controls tuned to the organization's evolving security needs. A well-architected NAC system is pivotal in both the monitoring and enforcement phases of a zero-trust journey. It serves as the central decision-maker, validating access requests and determining contextual identities based on various organizational parameters. Implementing NAC can vary by medium, whether wired, wireless, or remote access, and each requires careful strategy to ensure seamless integration of zero-trust principles into existing infrastructure while not disrupting business operations. Environmental factors play critical roles when deploying zero-trust architectures. Greenfield deployments allow starting from scratch and offer opportunities for meticulous planning and implementation of policies, while brownfield deployments require integrating new policies into existing infrastructures. Each approach necessitates careful evaluation of the deployment stages, challenges related to operational continuity, and efforts to harmonize security requirements with existing processes and resource constraints. Contextual identity is multifaceted, incorporating factors like user identity, device type, location, access time, and network interaction methods. Practical application requires extensive analysis of these attributes to validate identities effectively. The nuanced understanding gained informs network policy decisions, ensuring that identities are substantiated and authorizations are appropriate. This comprehensive approach supports robust security measures aligning with organizations' specific operational contexts and security ambitions. Authentication and authorization are core components of contextual identity, where authentication verifies an entity's identity before granting access, and authorization determines the level of resources access allowed post-authentication. Organizations should assess existing capabilities and future needs to implement effective authentication mechanisms, ranging from the use of Active Directory to certificate-based methods. Additionally, authorization should be strategically managed to allow access where justified while preventing unauthorized access, thus maintaining a secure network environment. Segmentation is a vital component of the Zero Trust framework, facilitating controlled access based on specific contextual criteria. Effective segmentation starts with classifying identities into manageable groups that align with operational capabilities and security objectives. In greenfield scenarios, segmentation can be implemented systematically, while brownfield deployments require careful integration into existing processes. Each method requires a balanced approach to achieve secure, efficient network segmentation, while accommodating operational nuances. Unified communications, UC systems, present unique challenges in Zero Trust environments due to their extensive protocol requirements and varied communication needs across different devices. Managing UC within a Zero Trust architecture involves categorizing devices accurately and applying flexible policies to accommodate their interactive requirements. Enhancing data exchange between systems through standardized protocols, like PX Grid and STIX Taxi, supports improved visibility and contextual identity by facilitating access to comprehensive identity data needed for enforcement. Zero Trust enforcement requires a stepwise approach to ensure successful implementation and continued alignment with security goals. By thoroughly understanding and applying key concepts such as contextual identity, segmentation, and monitoring to existing frameworks, organizations can robustly defend against unauthorized access while maintaining operational efficiency. Continuous evaluation and adaptation to emerging threats and organizational changes are necessary to achieve sustained security improvements and support business objectives. Throughout this process, meticulous planning and effective policy management are essential to converting Zero Trust principles into actionable outcomes.